In this lesson, we're going to be looking at the parts of a circle: arc length and area, and actually something new called radians, which is another way to measure angles. So to start with arc length, an arc is an unbroken part of a circle consisting of two endpoints, so in this case A and B, and all of those points between them. It measures distance or length, not degrees. So this A to this B, it goes along the edge of the circle. It's not a straight segment, it's an arc. And we want to know how much imagined string we would need if we need to go that distance. So the question is, what is the length of an arc if it goes all the way around a circle? So we're trying to figure out how to measure these curvy pieces. Well, one thing we know is that the distance around a circle is the circumference. So the length is 2 pi times the radius. If I asked you for the length just halfway or a quarter way around the circle, what would you do? Well, you'd say, well, I know my length. We can make a proportion. My length of my arc over the whole thing would be the same fraction as if I say a halfway or a quarter way around the circle. So this is the proportion I would set up for halfway around the circle, and this is the proportion I could set up for a quarter way around the circle. So the question is, how can I make these fractions for the general case? Because it's not always going to be an easy one, like a half or a fourth. Well, so I can go ahead and set up a proportion because it is proportional. And I'm going to say the arc length over the whole is the angle over the whole. In this case, x degrees over 360 degrees. So let's go ahead and apply this as an example. Oh, by the way, this is an L, and that's the curvy line saying the arc between A and B. So that's one way to note arc length. We tend to use M when we're talking about degrees. Now we're going to look at an example for arc length. Sarah is putting a yellow tape along the edge of the balloon section, so that's right here. The arc for the doll is 80 degrees, and for the toy car is 120 degrees. The question is, how much yellow tape will she need if the radius of the spinner is 10 inches? So I know the distance from the center to here is 10. Well, one thing I need to know is the measure, or the number of degrees in that arc. So I know that all three have to add up to 360. 80 plus 120 plus B is 360. Solving for B, which I won't do on here, I know you can do it well enough. 80 plus 120, that's 200. Oh, this needs to be 160 if they all add up to 360. The next step is to set up my proportion. This gives me the measure in degrees, but I'm looking for the length. So it's going to be some measure of inches. And in fact, I could kind of guesstimate this. I know the distance all the way around is 2 pi times the radius. So let's say pi is about 3. 2 times 3 is 6 times 10. All the way around is about 60 inches. And I'm almost halfway around. So my answer, I bet you, is less than 30 inches. So let's set up our proportion and find out. The arc length over the circumference is equal to the measure of the arc over the total measure for a circle, which is 360. Now I'm going to substitute in my values. L over 2 pi times 10 is 160 over 360. Now I can say this is 20 pi, and I'm trying to solve for L. So I'm going to multiply. Oh, one quick trick I forgot to tell you. When you have zeros, extra zeros on top and bottom of a fraction in the numerator and denominator, you can simplify them. It's kind of like I divided the top and the bottom each by 10. So that's a nice quick thing you can always do. It works. And it'll just save you time and keep your numbers a little smaller. So anyways, I'm trying to solve for this L, but it's being divided by 20 pi. Well, the way I undo division is multiplication. So I'm going to multiply both sides by 20 pi. This is going to simplify, and I just get L is 320 pi over 36. Now I could simplify that further if I wanted to. Both of those are divisible by 4. So it looks like it's 80 pi over 9. But I'm going to go ahead and give this in inches, and when I use my calculator, I get about 27.9 inches. So what is the arc length, and how do you find it? Don't mix it up with arc measure. They're related and they're proportional, but they're not exactly the same.